Hello everyone, welcome back to our Plotly tutorial series. In the last video, we learned how to create basic and customized histogram to analyze students' math scores. We explored how to overlay histogram, adjust bin size, use gender-based color, and even interpret density using KDE plots. So in this video, we are going to step further. We will explore advanced histogram techniques using the same student performance dataset. So you will see how to combine histogram with box plot, use facet plots for multivariable comparison, plot cumulative distribution, and even bring in animation and slider to enhance interactivity. So before we plot, let's understand why we might want to combine a histogram with a box plot. So a histogram shows the distribution of values, how frequently each score appears, but a box plot adds a summary statistics, median, quartiles, and outliers. So by combining the two, we can quickly understand both distribution shape and statistical range. So let's break this down in details. So we begin with x equals to writing scores, which tells Plotly that we want to plot the distribution of students. Writing score on the x-axis. So this is the numeric data that we are analyzing. The histogram will break these scores into intervals or bins and show how many students fall into each range. So this helps us quickly understand whether most students scored high, low, or somewhere in the middle. Next, we add marginal equals to box. So this is an incredibly powerful addition. What it does is place a box plot at the top of the histogram. The box plot summarizes the key statistical aspect of the data: the median, the interquartile range, which include the 50% of the data, and any potential outliers. And the line inside the box show the median score, and the ends of the box represent the 25th and the 75th percentile. So this way, even before dividing into the shape of the histogram, we already get a statistical summary of the distribution. And lastly, the title argument is set to give the chart a descriptive heading, which helps us viewers understand the purpose of the visualization at a glance. Now let's run this code. So what we see is a chart where the histogram bars represent the counts of students for each writing score range displayed on the y-axis. The x-axis shows the writing scores, typically ranging from 0 to 100. On top of the histograms, we have a horizontal box plot that adds an additional layers of statistical insights. It highlights the median score, interquartile range, and the presence of any outliers which are visible and individual dots. So this combinations effectively shows the both frequency distribution and summary statistics in a single visual, helping us understood not just how scores are spread but also whether the distribution is skewed or contain extreme values. Now we will be exploring how student math scores vary based on the two important factors: whether the students completed test preparation course and their gender. So often educator or analyst want to know if intervention like test preparation actually make a difference and whether that differences looks the same for boys and girls. So to do this effectively, we need to break down our data by both test preparation status and gender. So that's where a faceted histogram comes in. So by creating a small multiples of the sum charts across subgroups, we will be able to compare patterns side by side. So this make it easy to spot differences in a distribution across these two dimensions. This next plot helps answer the question, how does test preparation affect math performance and does it vary by gender? So we begin with x equals to math scores. This tells broadly that we want to analyze the distribution of math scores. So our x-axis will represent the range of possible math scores that student received. Next we use color equals to gender. This is really important for comparison. It allows us to break the histograms bars into two groups, male and female students, and the bars will be displayed using two different colors, which help us quickly see if one gender is more represented at a particular scores level than the other. Then facet underscore column equals to test preparation course. So it instructs Plotly to create a separate subplots for students who completed a test preparation course versus those who did not. So this way we are not just seeing an overall view, but we are also getting segmented visual that help us understand whether test preparation had any impact and how that impact might differ between male and female students. So when we run these charts, we get a side-by-side comparison of math scores based on a test preparation course status. One subplot for students who did not take the course and another for those who completed it. So with each subplots, the histogram bars are segmented by gender, blue for females and red for males. So these layouts allow us to analyze both gender-wise and preparation-wise performance trends in a single visual. For example, we can observe that amongst students who completed the course, both male and female students tend to score higher in math compared to those who didn't. So additionally, we can visually assess if the gender gap narrows or widens depending on whether the course was taken. So this kind of charts is especially useful in educational data analysis, as it enables us to quickly interpret multidimensional relationship that would be difficult to uncover from raw data alone. Let's now look at a community distribution. So this kind of charts show how scores accumulate across the dataset. So it answers what percentage of students scored below a certain value. So let's walk through what this community histogram is doing and why it's powerful visual. First, by setting community equals to true. So we are changing the behavior of this histogram so that it doesn't just show how many students scored in each specific range. Instead, it show the running total of students who scored less than or equal to a given value. So this transforms the chart into a cumulative distributions, which is extremely helpful when we want to understand percentiles or compare thresholds. For example, if a school wants to know what percentage of students scored below 60, a community histograms can help us find that instantly by checking the height of the bar at 60. So next, x equals to math scores means we are plotting these community distributions based on the math scores, which remain our main variable of interest. And the x-axis will show the range of math scores, while the y-axis will show the cumulative count or proportion of students up to that score. After running this chart, we get a community histograms of math scores where the bars build progressively from left to right. Unlike a regular histogram that show the frequency in each wheel, this plot show how the total number of students accumulate as the score increases. And the y-axis represents the cumulative counts of students, and the x-axis show the math scores. As we move to the right along the score axis, the counts keeps increasing since we are adding more students with each score win. So these upward patterns help us understand how scores are distributed across the entire student population. For instance, if the cumulative bar at score 70 reaches close to 750, it means about 750 students scored 70 or below. So this kind of visualization is particularly useful for reporting, setting scholarships threshold, or analyzing performance tiers, as it clearly shows how students falls below or above a specific score. Now let's bring animation into the mix. So this visualization will show how reading scores as distributed across different race ethnicity groups, and it updates frame by frame. So let's take a close look at how this animated histograms works and why it's useful. So we start by setting animation underscore frame equals to race ethnicity. So this tells Plotly to break our data into a separate frame, one for each racial or ethnic group, and animate it through them one by one. As the animation plays, you will see the histograms update automatically to show reading score distribution for each group individually. So this is extremely helpful when we want to compare patterns across multiple categories, but want to avoid cluttering a single static chart. Next, we use color equals to gender, which breaks each bar in the histogram into gender groups, typically male and female. So we can compare their performance side by side within each ethnic group. Each group will be color coded, making it easy to spot differences or similarities in how males and females scores in reading across different racial or ethnic backgrounds. So after we run this chart, we can see a stacked histogram of reading scores split by gender, blue for females and red for males, along with an interactive animation panel just below the plot. And the key features here is the race ethnicity filter, which lets us explore the score distributions group by group A through group E. You will notice a play button and a slider control that allow you to cycle through each race ethnicity group like a slideshow. So this makes the charts dynamic and exploratory, helping viewers observe how reading scores distribution vary not just by gender but also across different racial ethnic groups without displaying all the data at once. So for example, you might find that groups B has a wider score spread, or that group D show a smaller gap between male and female students. These insights become clear only because we are able to focus on one group at a time. So making this kind of animation extremely useful for narrative driven data exploration, especially when working with a multidimensional dataset. Now let's finish with another animated histogram, but this time we will include the range slider so users can zoom in a specific score ranges. So for that we are using a similar setup as the animated histograms we just explored, but now we are adding an extra layer of interactivity by customizing the layout to include a range slider. Let's break it down by step. So the function update underscore layout function in Plotly allow us to fine tune various aspects of our chart's appearance and behavior. So in this case we are specifically modifying the x-axis property. Within the x-axis dictionary, we add the key range slider equals to dict visible equals to true. So this line enable a horizontal slider bar right below the x-axis. And the range slider is an interactive. It allows users to click and drop and drag to zoom in a specific range of the x-axis, which in our case represent the reading scores. So why is this useful? So let's say you are particularly interested in a students who scored between 50 to 70. Instead of showing the full range all at once, so the range slider allow you to focus your view and explore that particular slice of data. So this makes the visualizations more useful, more user driven and dynamic, especially when paired with animation by race and ethnicity. So now when we run this code, we not only get an animated histogram that transition by race ethnicity group, but we also see the addition of a scrollable range slider at the bottom of the plot. So this slider lets users zoom in a specific reading score ranges while still interacting with the animation across different race ethnicity categories. So the histogram's bars remain stacked bar gender, blue for females and red for males, making it easy to compare patterns within each group. The inclusion of both the animation control and range slider transform this chart into a powerful interactive data exploration tool. User can now analyze the across both categories, frames, and numerical value ranges, making the analysis far more flexible, focused. So this kind of visualization is especially effective for representations or dashboards, where insightful comparison and dynamic filtering are crucial. So in this video, we took a deeper dive into histogram-based visualization using the Plotly library and the student performance dataset. We begin by combining histograms with box plot to simultaneously explore frequency distribution and summary statistics such as a median, quartile, and outliers. So this helps us better understand how students' writing scores are spread and where the majority of data points lie. Next, we introduce facet histograms to examine how math score distribution differ not only by gender but also based on whether a student's completely test preparation. So this dual variable breakdown gave us clear visual insights into the effectiveness of a preparation and any gender related trends. We then explored community histogram, which allowed us to track how students' scores accumulate as the value increases. So these are especially helpful when answering percentile based questions like what percentage of students scored below specific threshold. We moved on animated histograms where created race ethnicity based frames for reading score distribution. So this animation made it easy to isolate and observe patterns within each demographic groups, all while retaining gender segmentation. And finally, we added range slider to our animated histogram, giving user the ability to zoom into specific score ranges. So these features enriched interactive and made our charts more dynamic and useful for exploratory data analysis. These advanced histograms techniques enhance our ability to interpret multidimensional student performance data with clarity and interactivity. So I hope this session was helpful for you. If you have questions, leave them in the comment below. Thank you for watching and see you in the next video.